to do is you need to go to aplusstudents.com. You need to go to the website. Once you're on the website, you need to select math as your subject. This is a grade 8 math lesson, and the name of the topic is probability. I'll give you the chapter number and the lesson number. Chapter number 26 and lesson number 1. And the name of the lesson is experimental probability. Okay, let's go to maths, grade 8, chapter 26 and lesson number 1. Okay, how do we find the probability? Any an event, any event is anything that is happening, anything that is happening around us, happening, okay, around us. Anything that happens is called an event. The word probability has synonyms. Probability can be interchangeably used as possibility or chance. So what we say is, what is the chance of something happening? What is the possibility of something happening? Or what is the probability of something happening? It's exactly the same thing. The probability of anything that is happening, of an event, can never exceed 1. It has to be less than 1, and it has to be greater than 0. The probability of an event cannot be less than 0. Okay, if it cannot be ever, it can never be in negatives. Okay, if we need to find the probability, the formula to find the probability of any event is favorable outcomes. That means what we need to find upon divided by the total number of outcomes or possibilities. Okay, let's look at an example. We start off with the basics. Okay, let's say if we have in question number 1, let's say we have a coin. A coin is always flipped. Okay, a coin is flipped. Find the probability of getting a tail. So we know that on a coin always has two possibilities. Either we can have a head or we can have a tail, right? So if we need to find the probability of tail, how many tails are there on a coin? There is a single tail, right? That means we are looking at the favorable outcomes. We need to find the probability of a tail. There was one tail, and how many total outcomes were there? There were 2 total outcomes. That means the probability of tail is 1 upon 2. Similarly, if we would want to find probability of heads, so how many heads were there? There was 1 head out of the total 2. So the question can ask us tail or head, right? So let's take it further and let's see. So the next question it says, experimental probability will be the number of times an event will happen again and again, right? So for question number 2, let's see if this word problem is given to us. Let's realign this. Okay, just a minute, please. A grocery store recently sold 18 cans of soup. 9 of those cans contains tomato soup, right? They have tomato soup, and they're asking us what is the experimental probability that the next can sold would be a tomato soup. Okay, let's suppose this was our question number 2. The shop is selling 18 cans of soup, right? Out of those 18 cans, 9 of which were a tomato soup, right? We had to find what is the experimental probability that the next can sold will be a tomato soup. So experimental probability is like probability. They're just using an additional word over here. That means we need to find the probability. What is the possibility? What is the chance that the next can, the 10th can that would be sold, will be a tomato soup as well, right? So what we do is we find the probability of tomato soup. 9 of them were tomato soups, right? Out of the total, what was the total number of sold? There were 18 cans sold. So can we simplify this? 9 upon 18 would be equals to 1 upon 2. Agreed? That means then the probability for the next can sold would be 1 upon 2 as well, right? Agreed? We just simply need to find the probability. What is the possibility or what is the probability? Do we agree on this? Okay, let's have a look at another example. Okay, for the next question it says, question number 3, they're saying a band sold out its 9 out of 15 shows. What is the experimental probability or what is the probability that the band's next show will also be sold out? Question number 3. How many shows did they sell out? Sold out 9 out of 15 shows, right? So if we need to find the probability of sold out shows, so how many shows were sold out? 9 were sold out of the 15 shows, right? It comes out to be 9 upon 15. Can 9 upon 15 be further simplified? We know we can write this as 3 times 3. Remove the 3 and the final answer comes out to be the probability of a show being sold out, the tickets being sold out for this particular band is 3 over 5. Okay. We can also give this answer in percentages. There's a 60% chance. How do we find the 60%? We write 3 upon 5. Whenever we change anything into percentage, we multiply by 100%. 5 times 1 is 5 times 20. We write 3 into 20%. We can say that there is a 60% chance that next show will be sold out as well. Okay, we can give the answer in fractions, we can give the answer in decimals, or we can give a percentage. Depending on the question, we would give our answer. If they're asking us to give us our answer in a fraction, we leave 3 upon 5. We simplify 9 upon 15 and we leave the answer as 3 upon 5. If they want the answer to be in decimals, we write 0.6. Or if they want the answer to be in a percentage, we simply change the probability into a percentage. Agreed? Okay. Any questions till now? Done. Thank you. Let's move ahead. Okay. For the next question, it says, let me just copy and realign first. During 10 spins, a spinner lands on orange 4 times, right? Let's suppose I'll draw a spinner. I'll show you what exactly is a spinner. This a circular. We have partitions in it. Let's suppose. Okay, let's suppose if this was given to us, this and this, right? On a spinner, we have a arrow that can be spun. Orange, we pick up different colors. I'm just picking up different colors because they have given us orange, right? Okay, what they are saying in the question is, during 10 spins, a spinner landed on orange color 4 times. Okay, so we can say that probability of spinner landing on an orange in this question can be 4 out of 10. That means if we spin the spinner 10 times, 4 times it will land on orange color. Agreed? They're asking us to find the experimental probability. Okay. And 4 upon 10 was the answer. Can this be further simplified? That becomes 2 upon 5. Agreed? So we did the first part. Let's add more questions to it. Okay. The second information given to us is the spinner lands on green 5 times. Okay, the spinner lands on green 5 times. They're asking us find, or what is the experimental probability, or what find, oh sorry, find the probability that the spinner will land on blue. Okay, so the given information that we had was the probability. We found the probability of orange because they are saying on an orange it lands 4 times out of 10. Agreed? On green it lands 5 times. This is the additional information that was given to us. Okay, it lands 5 times on the green. What they're asking us, find the probability that the spinner, how many times would the spinner land on blue? We know that we have 3 colors. We have orange, we have green, okay, or we have the blue. These are the only 3 options that we have on the spinner. Agreed? The orange was, okay, when you spin a spinner, can you get the three colors together? Can you get the orange, green, and blue together, or the spinner will only land on one color? Because there is a single needle, right? When you spin the needle, it will stop at any one of the colors. It can stop at orange, it can stop at green, or it can stop at blue, but it will stop at one of the colors, right? So we can say it could be orange, or it could be green, or it can be blue, but not all of them can be together, right? The probability of orange was orange lands 4 times out of 10, right? Green lands 5 times out of 10. Blue is missing. We need to find the probability of blue. Whenever we are doing or, we do the addition. And I told you the probability of any event, in this case, the probability of the spinner, right, has to be between 1 and 0. So a complete event has a probability of 1. So can we add the numbers and subtract from 1 to find the probability of blue? Can we say 1 is equals to 9 upon 10 plus blue? Okay. And in order to find the probability of blue, can we say 1 minus 9 upon 10? That would be the probability of blue comes out to be 1 upon 10. That means blue has a single chance. That means if we spin the spinner, it will land on orange 4 times. It will land on green 5 times. And there is a 1 chance out of 10 that it would land on blue color. Okay. So we need to remember that a probability of a complete event would be 1. So if we add all the probabilities together, the sum of the probabilities should be 1. Okay. Let's look at another question. There were 6 dogs at the park. Just a moment, please. The next question, it says, let me just realign this and resize. Okay. Just a moment, please. Okay. So if this is our question number 5, they say in question number 5, this is the statement that's given to us. There were 6 dogs at the dog park last Saturday. Okay. 2 of them were actions, right? What is the experimental probability that the first dog to arrive at the park next Saturday will be a dash note, right? For this, can we find the probability of the dog? How many total dogs were there? We always write the total in the denominator. There were 6 dogs. And out of those 6, how many of them were Dachshunds? There were 2. That means the probability of getting this particular breed of dog would be 1 upon 3. Simple, right? We simplify 2 upon 6 to 1 upon 3. If they would have given us more breeds, then we would simply compare them. Okay. Just a moment. For the next question, it says, question number 6. Okay, just a moment, please. Bonnie flips a weighted coin. A weighted coin means it's unbiased. 15 times. What is the experimental probability that the next flip will come up to tails? Okay, let's see. This is our question number 6. Bonnie is flipping a coin. We know that a coin can always have two possibilities. Either it would be a head or it could be a tail. There are no other possibilities on a coin, right? So what they're saying is, if the coin was flipped 15 times, there were 3 tails. So that means, as per this experiment that was being done, if the coin was flipped 15 times, the total was 15, then 3 times was tails, right? That means we can further simplify. It comes out to be 1 upon 5 is a, but in the next, what is the probability that the next flip will come out to be a tail? This is. But if they say, what is the probability that the next flip will be a head? So how can we find the next flip as a head? We know that the total probability, head plus tails, should always be equals to 1, the probability of an event, right? If the probability of head we need to find and the probability of tail was given to us, that was 3 over 15. Let's take 3 over 15 because 1 upon, okay. So can we subtract this? 1 minus 3 over 15. 15 times 1 is 15. It comes out to be 12 upon 15, which comes out to be the probability of head. Can 12 upon 15 be simplified to 4 upon 15? 4 upon 5, right? That means that if the probability of head was 1 upon 5, then the remaining probability, 4 upon 5, will be the probability of getting a head. Okay? Because a coin has only two options. Either it could be a head or it can be a tail. There is no other option, right? Next question says, question number 7. Of the last 10 contestants on a game show, 8 qualified for the bonus round. What is the experiment probability that the next contestant will also qualify? Question number 7. How many contestants are there? We always find the probability by using the formula for the probability. The formula was favorable outcomes divided by total number of outcomes. Agreed? This is how we find the probability. 10 contestants were there and 8 qualified. So how can we find the probability of qualified? We need to find the probability of qualified. It would be 8 out of 10. Agreed? Which can be simplified to 4 upon 5. But if I say we need to find the probability of who did not qualify or fail, right? Did not qualify or failed. How can we find that? What we can do is we subtract the probability of qualified from 1, because the sum of the qualified and failed would be always equals, sorry, my spelling error, qualified, because the total of the probabilities is always equals to 1, right? So what we can say is 1 minus the probability of qualified, that there is only, we subtract this, take a least common multiple, it comes out to be 1 upon 5 is the probability of the next contestant to be failed. But this was our actual answer. I'm just on what was the next contestant will qualify, right? I'm just adding an additional part to the question for an understanding. Okay, let's have a look at one more example. Just a moment, please. On the last day, it's about, let's move ahead with question number 8. I'll just realign this. Okay, just a moment. I'll resize so that we can read it. What is the experimental probability? Okay. Question number 8 says this information. On the last day of Shakespeare's class, an English teacher asked her students which play they liked the most. Out of the 14 students who have submitted their responses so far, 4 like Much Ado About Nothing, right? What is the experimental probability that the next student to respond likes Much Ado About Nothing best, right? So we can say we need to find the probability of, I'll just use the first alphabets, right? About the novel or the novel. That was, how many liked? 4 of them liked the novel out of the total 14, which can be simplified to 2 times 7. Sorry, my bad. 2 times 2 is 4, and 2 times 7 is 14. 2 is common, and the final answer comes out to be 2 upon 7. Agreed? That means 2 out of the 7 students would like the null, right? Okay, let's move ahead. Let's look at another example. For the next question, it says, of the last 15 trains which pulled into the station. Just a moment, please. The question says this information. Question number 9. Of the last 15 trains to pull into the station, there were 15 trains, 12 were full. What is the experimental probability that the next train will be full as well? We can say probability of having a train that was full, that was 12 were full out of 15. Agreed? And we can simplify this. 4 times 3 and 5 times 3 comes out to be 4 upon 5. That means the train that pulls in next into the station has a probability of 4 upon 5. that it will be full, right? So let's see, what about fail? If I would say, find the probability of not being full, how can we find this? Okay, can anyone answer me, please? Okay, can I be excused for a 10 seconds maybe or 15 seconds? Can you try this? I'll just be back. Yes, thank you. Because we know the probability of the entire event was 1, right? So the probability of, so what we can say is probability of the train being full, or the probability of the train being not full, right? We're not talking about empty, is always 1, agreed? The probability of train being full was 4 upon 5, which was the simplified value which we found over here. Agreed? Or means addition. This or this. Probability of not full was 1. So we can say probability of the train being not full is 1 minus 4 upon 5. That comes out to be 1 upon 5. Agreed? So if we have one of the values, we can find the counter value of it. Because the train has only two options. Either it is full or it's not full, right? If the probability of full was 4 upon 5, then the probability of not full would be the remaining part of the 1. Agreed? Okay, I'll just try to explain this through some boxes, okay? Let's suppose if we had these boxes, let me just make this. That would be 3 columns, okay? 1 column, 2 columns, and 3 columns. I'm trying to explain you the probability through this diagram, okay? So if I say these were the full, okay, we made 15 boxes over here, agreed? Out of these 15 boxes, let's suppose these 15 were different trains. How many were full trains? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? These were full, the trains which were full. Agreed? So if these trains were full, the total was 15. Agreed? There were 15 trains. So how many trains would be not full? 1, 2, and 3. Agreed? So these are not full, not full, and not full, right? So if we had to find the probability of not full train, that would be 3 out of the total was 15. And it still comes out to be equals to 1 upon 5. Same answers, right? So what we can say is that if one of the value is given to us and there are only two options available, then the remaining part will be for the probability would be the remaining part for the second option, okay? Let's have a look at another example. For the next question, it says, of the last 6 digits, oh, sorry, last 6 flights. I read the wrong question. Okay. Let's say in question number 10, let me just realign this. Okay. There were 6 flights arriving to a town. Question number 10. Okay. 3 of the flights were late. 6 flights to arrive, total 6 flights. 3 flights were late. What is the experimental probability that the next flight to arrive will be, I'll just change this part, will be on time? Okay, perfect. I welcome. See, I changed the question over here. No, total always stays down, right? See, I'm just doing this to explain. Or can I change this number to a 4 so that we have a different answer? Okay, let's try this, okay, from the scratch. So if I say probability of flights that were late, how many flights were late? 4 of the flights were late out of the total 6. 4 were late out of the total. The total always comes down in the denominator. Now it's not. Yes, you were right, Brain. You were perfectly right, but I've changed the number now so that we have a bit, because half and half will complicate things for us, right? I changed the value so that now we have different fractions, not same fractions, right? Yes, perfect. Late means 4 upon 6. That means it can be simplified to 2 upon 3. But the question is asking us, how many flights will be on time? That means we need to find the probability of on time. As per the rule, we know that probability of late plus probability on time, the total of the probabilities should be 1. The probability of late was 2 upon 3 plus the probability on time, agreed, was 1. So can we say probability of on time would be 1 minus 2 over 3, right? That is 1 minus 2 over 3, which simplifies to, we take an LCM, that is 3 minus 2. It comes out to be 1 upon 3. Agreed? This comes out to be 1 upon 3. Agreed? So I just changed the question. That means late and on time, the total should always be equals to 1, because the probability of any given event cannot exceed 1. Okay. Or what we can say is, we know, sorry, if we know that 4 were late, agreed, then 2 were on time, right? Make your life easier. Total flights, 6 flights. So if we had to find the probability of on time, we can directly say 2 out of 6, that is 1 upon 3. Whichever way you can do it, right? Okay. Let's try a question or two more, then we'll go back. Let me copy the next question. Okay. I'll just make some changes to the question number 11. Okay. Don't start with the question. I have to make some changes first. Out, if I say 7 out of last 10 customers wanted mustard. What is the experimental probability? Or they use the word, what is the probability? It's exactly the same, does not make any difference. Okay. So for this question, it says, question number 11. At a downtown dogs, 7 of the last 10 customers, that means 7 out of 10 customers wanted mustard on their hot dogs. They wanted, right? They prefer. What is the probability that the next customer will not want? Okay, I'm just changing. Will not want mustard. So we know that 7 people wanted mustard, right? So mustard, those who like mustard were 7 out of 10. Then the remaining who do not like mustard would be the remaining value. That would be 3 out of 10. Agreed? Simple. Rather than doing the working, if it's a single mark question, we directly do that. Okay. But most important is we need to see what they're exactly asking us in the question, right? That is our most important part. Okay, let's try some questions from the test. Maybe a few questions from the test. Just a moment, please. I need to log in again. Okay, maths, grade 8. I think chapter number 26, lesson number 1. Test, let it load. Okay, the first question says, on a game board spinner, okay, a spinner is given to us. Let this be our question number 1. And these are the answers given to us. Okay. Simplify your answer, give it in simplified form. The price is given. Let me just recite so that it's readable for you. Okay. This is our first question. Question number 1 from the test. So what should be the answer? They are saying that on a game board spinner, Kenny won a prize on 4 out of 14 spins. Kenny did 14 spins and Kenny won 4. What is the experimental probability that the next spin will yield a prize? Right? So would it be 2 over 7 or 2 over 5? That means probability that Kenny won. How many times did she play or he play? That would be 14 times. And winning was 4 times. Okay. That means total were 14 and 4 times they won, right? When we simplify this, can we write 2 multiplied by 2? 2 multiplied by 7. We cancel out the 2's and the final answer is agreed. That means the probability of winning is 2 over 7, right? I did this question for you. Next question, please do it for me so that we have an understanding. If you understood or not. Okay. For the next question, they're saying that there were 15 trains that pulled into a station. Okay. These are the probabilities given to us. This is question number 2 from the test. Of the last 15 trains to pull into Westminster Station, 12 were full. We need to find what is the experimental probability that the next train will be full. So what should be the answer? for train being full? Okay. No, the probability or the experimental probability is always in fractions. We do not have 2 upon 9 or 2 upon 7. Out of these three options, 4 upon 9, 3 upon 7, and 4 upon 5, which should be the correct answer? See, we say that probability of a train being full. Okay. How many total trains were there? There were 15 trains, right? And how many trains were full? They're saying 12 of the trains were fully occupied. 12 were fully occupied, right? Can we simplify? Can we write 3 times 4? Can we write 3 times 5? If 3 is common, we remove and we get, thank you. Yes, it is 4 upon 5. Okay. So can we find 4 upon 5? Yes, we can. So we say that this is 4 upon 5. If I consider the same question, okay, and if I say for the same question, if this was our part A, if I would say part B, what is the probability that the trains will not be full? Okay, I'll just make a few options over here. Okay, can I say 4 upon 15, 1 over 5, or 2 over 5? Same question. I'm continuing with the same question, and we are trying to find another value in the same question. What is the probability that the train will not be full? If 12 trains were full, then how many trains were not full? Not full would mean out of the total 15, if 12 were full, then 3 should be not full. Right, Malay and Brain? If 12 were full, then not full should be 3, right? Out of the 15. We can simplify this as 1 multiplied by 3 and 5 multiplied by 3. We cancel this out. We are left with. Do we have 1 upon 5 as the answer in any one of the options? Yes, we do. Agreed? We simply click onto that particular option. Okay. Please do try the remaining questions so that you have more practice. Okay. Thank you so much. Best of luck. Have a nice day. Take care. Bye.